Okay, dear students, welcome to Icgt Lecture number 7. We are going to talk about the turbines. This is the 6th unit. We have read different parts of internal combustion engine. Now we will be reading the different parts of turbine. That is basically gas turbine, which produces power. The first chapter of this unit consists of Brayton cycle. It's the component of a gas turbine plant. Those we will be studying. Now first comes to Brayton cycle. In the Brayton cycle, you can see it has a PV diagram showing here, pressure volume diagram and temperature entropy diagram. There are two diagrams shown here. You can see 1 to 2 isentropic compression, that is adiabatic frictionless compression. The process 2 to 3 constant pressure heat addition. 3 to 4 isentropic expansion, and 4 to 1 is the heat rejection, constant pressure heat rejection. That means it has two constant pressure processes, two isentropic processes. See in the TS diagram. Let's see in the TS diagram. 1 to 2, this is isentropic compression. Because of the compression, you can see PV and TS diagram. From PV diagram, you can see 1 to 2. P2 is greater than P1 because pressure increases tremendously high from P1 to P2. That is because of compression. And the compression process 1 to 2, at that, because of compression, the temperature also increases. That shows in the process 1 to 2 in the TS diagram. You can see the temperature is increasing from 1 to 2. At point 2 to 3, there is a constant pressure at this part of the curve. You see PV diagram 2 to 3, this is the constant pressure curve. At the constant pressure, there is heat addition. Taking this into consideration, we can see 2 to 3 is constant pressure heat addition, and as a result there is a rise in temperature from TS diagram. T3 is greater than T2. There is a rise in temperature from T2 to T3. This temperature rise happens because I am adding heat at constant pressure. Try to understand there are two phenomena. 1 to 2 is isentropic compression, means adiabatic frictionless compression. You know what is adiabatic frictionless isentropic? You read in thermodynamics in earlier classes, in earlier years. Now, 1 to 2 is a isentropic compression, and as a result of isentropic compression, the temperature increases. So that shows in the TS diagram 1 to 2, where T2 is greater than T1. Because of the compression, temperature increases. Then it comes in the process 2 to 3. This is a constant pressure heat addition. Because of the constant pressure heat addition at the 2 to 3, there is temperature increase T2 to T3. And here T3 is much greater than T2. Then it comes to the process 3 to 4. At 3 to 4, the pressure drops. This is an expansion process, 3 to 4. Because of the expansion, the pressure drops. You remember, in compression, the pressure rises. We compress air, so pressure rises. This is the process 1 to 2. In 3 to 4, we expand, so the pressure falls, drastically falls. That is why you can see from 3 to 4, in the PV diagram, there is reduction of pressure. Then you can see in this TS diagram, from 3 to 4, there is reduction of temperature as well. You can understand, when there is compression, there is rise in temperature. When there is expansion, there is fall in temperature. These are general phenomena of science. Following this, during 3 to 4, the temperature and the pressure both drop. It's clear from the PV diagram and TS diagram here. 3 to 4, drop in pressure, where S is equal to constant. S is equal to constant means isentropic, entropy is constant. And 3 to 4 also temperature drops. And 4 to 1 is constant pressure heat rejection. 4 to 1 is the constant pressure heat rejection. That is that P equal to constant, the heat gets rejected in 4 to 1. The constant pressure heat rejection happens at 4 to 1. Now, here comes the total system of a gas turbine plant. You can see in the plant, I'll show with the different parameters. You can see this is the turbine part. This is the turbine part. This is the combustion chamber where combustion takes place. This is the compressor where the compression happens. This is the shaft, main shaft. Now, the compressor shaft, which is shown here, rotates here due to the power generated by the engine. As the compressor shaft rotates, as a result of that, the turbine rotates. It doesn't rotate because of the compressor shaft rotation. Actually, the power comes from the main shaft or the engine shaft. From the engine shaft, the compressor starts and then it comes to turbine. Turbine rotates due to the expansion process. And this happens in general, which will be clear in further diagrams in our future lectures, in our future classes. You will get more concept of this. I am just showing the physical concept, how the compressor is located, how the combustion chamber is located, how the turbine is located. Just a cut section of a three-dimensional view. You won't understand much about that. This is only a machine to you at this point of time. But as you enter into the engineering analysis of that, that will be more clear to you. Now, open and closed cycle gas turbine plants. There are two types of cycles of gas turbine plants. One is open cycle, one is closed cycle. Naturally, the name signifies, in case of open cycle, the turbine is open. That means the gas comes inside, it rotates the turbine and it goes out. That's the open cycle. In case of a closed cycle, the gas doesn't go out. It is being recirculated again and again throughout the system. That is why it is closed. Closed means no connection with the outside environment. The same gas is rotated and rotated again. Now, both the systems have their own advantages and disadvantages. Though the closed system is comparatively more preferred as compared to the open system. You get more types of more actions in closed system, more advantages in closed system as compared to open system as we go through our future studies. Define a gas turbine is a turbo machine and basically similar to steam turbine regarding its working principle. In steam turbine, what happens? High pressure steam enters, it makes the turbine rotate. Taking the same philosophy into account, in a gas turbine, the gas comes into the turbine. At high pressure gas comes into the turbine. It rotates the turbine blade, and as a result, the gas pressure drops. This is basically the expansion process I was talking earlier. It should be ideally an isentropic expansion process, but practically isentropic process is not possible. But it is the expansion process what happens in turbine. Why expansion, you understand? Because we provide a high pressure, high temperature gas, we pass through the turbine. When it passes through the turbine blade rotates. As the turbine blade rotates, the gas loses its pressure and it becomes a low pressure gas. The rotation of the turbine produces power. And you want power in the case of gas turbine. We are running the gas turbine to produce power. The first turbine to produce useful work probably a windmill where no compression and no combustion exist. Windmill. In case of a windmill, there is no compression, no combustion. A simple blade is there which rotates due to the pressure of the air, wind. There is the air pressure. As a result of that, rotation is produced, the power is produced. So windmill is generally kept near the seashore where there is high wind pressure. But here you are totally dependent on nature. If there is wind flow, the windmill will rotate. If there is no wind flow or less wind flow, the windmill will rotate slowly and will produce lesser amount of power. So it was initially used to produce power, but nowadays it is not of much use because we want power as per our demand. We want power as per our demand. And depending on the demand, we can make power, we can get the power as and whenever required and make our engine rotate. Now, a gas turbine includes a compression process and combustion process. Nowadays, what gas turbine is used nowadays uses a compression process and a combustion process. Compression process means there is increase in pressure, and combustion process means constant pressure heat transfer. As I was telling in Brayton cycle, I'll just show you Brayton cycle just to see. This is a Brayton cycle. This is constant. This is compression process 1 to 2. This is the compression process, and combustion process is 2 to 3, where constant pressure heat is being added constantly. Joule and Brayton independently proposed the cycle that is the ideal prototype. Joule and Brayton, these are names of the two scientists who made the cycle, and this cycle is highly successful in case of gas turbine plants. Now, gas turbine plants are used largely in power plants where there is certain power shortage sometimes due to failure of the plant, due to some emergency location, and due to small power requirement. Gas turbines are used. Remember that. Then we come to classification of gas turbine. What are the classifications? You can see, if we define on the basis of combustion process, if we define on the basis of combustion process is divided into constant volume and constant pressure. There are two types of combustion processes. One is constant volume and one is constant pressure. We generally use constant pressure cycle more as compared to constant volume cycle. General turbines use constant volume, constant pressure cycle generally. Then path of gases. There are different paths of gases. So one is open cycle gas turbine, one is closed cycle gas turbine, one is semi-closed cycle gas turbine. In open cycle gas turbine, the gas is compressed, then heat is added, the high temperature, high pressure gas comes to turbine, rotates the turbine, its pressure falls, and then it is taken outside where it rejects heat outside. This is the open cycle gas turbine. In case of closed cycle gas turbine, the gas comes within the compressor, gets compressed, the pressure and temperature rise, then goes to the combustion chamber where at constant pressure, high temperature, heat is added, so the temperature rises. Now the gas in the state of high temperature and high pressure after the combustion chamber. High pressure due to high compression and high temperature due to high heat addition and compression both. So as a result of that, high temperature, high pressure gas enters in the turbine, rotates the turbine blade, power is generated, and then it comes back to the heat exchanger. In the heat exchanger, it rejects it, and the same gas is recirculated through the compressor again. So what happens? The same gas is being used again and again, so you don't have loss of gas, much less loss of gas. The same fuel can be used, and there are many advantages and disadvantages connected with the open cycle and closed cycle. But advantages in closed cycle are comparatively more as compared to the advantages in open cycle. Then action of gases. One is impulse turbine, one is impulse reaction turbine. These things you have studied already in turbine and fluid mechanics. What is impulse turbine, what is impulse reaction turbine, that we are not going to discuss in this chapter. We are more interested about the running of the gas turbine, producing power with the help of that, how the cycle of the gas turbine works, and all these thermodynamic properties. For impulse turbine and impulse reaction turbine, you already know a lot of that from the fluid mechanics chapter. It's the same principle of steam turbine. That is impulse. In case of impulse blade, the blades are in one orientation. In case of reaction blade, the blades are in different orientation. That's all about this. Now, we come to the open cycle gas turbine. This is the open cycle gas turbine. You can see in case of open cycle gas turbine, the fresh air comes inside the compressor. It gets compressed. That fresh air comes at a state 1, gets compressed to state 2. You remember Brayton cycle, I have shown you. It comes at point 1 to point 2, there is temperature rise as well as pressure rise because of the compression. The compression happens, temperature, pressure both rises. Now, this high temperature, high pressure gas is passed into the combustion chamber. In the combustion chamber, with the help of fuel ignition, we are producing tremendous amount of temperature. Heat is added from outside to the gas. What we are doing with the addition of heat? We are increasing temperature. The gas is already at high pressure because of the compression. Now at the high pressure gas and to some extent high temperature also because of the compression, we add further heat so that it gets converted into high pressure, high temperature gas. High pressure, high temperature gas is always better to move a turbine, as a result of which, when it comes into the turbine and moves the turbine, as a result of which expansion happens. If the gas gets compressed, comes to combustion chamber, heat is added, then high temperature, high pressure gas comes to turbine. In the turbine, it rotates the turbine. As a result of that, the pressure of the gas falls, as well as the temperature of the gas falls. Now, as a result, temperature and pressure that falls. You know, as per law of conservation of energy, energy cannot be destroyed or created, but can be converted from one form to another. Taking that principle into consideration, the high pressure and high temperature energy gets converted into rotation of the turbine blade. You can see the pressure energy and heat energy is getting converted into rotary motion. And because of the rotary motion conversion, the shaft rotates. As soon as the shaft rotates, the shaft makes the compressor shaft also to rotate. Initially, how it started? With the battery, we started a compressor. But now, the compressor gets rotated with the help of turbine shaft. Turbine shaft helps to rotate compressor. At the same time, on the right side, you can say W net. Network is going out. That network, due to rotation of the shaft, is making the power to generate. How the power is generated? Say example, a magnet is placed in the shaft. The magnet rotates within an armature coil and current it produces. This is how the turbine works in its principle of working. Then the exhaust gases come out and the exhaust gases go out gradually. As the exhaust gases go out, this is sent into the atmosphere. You can see it is an open cycle. There is no revising of the gas or reforwarding of the gas, and there is no gas coming out. Whatever gas is coming in is going out. So it is a highly costly procedure because gases are continuously being thrown away after being used. So it's used in less places. We'll discuss about advantages and disadvantages in future classes. Now we come to closed cycle gas turbine. This is closed cycle gas turbine. Principle is same. It comes at the point 1. The compressor increases the compression pressure of that. At high pressure, high temperature at the point 2, it enters into the heat exchanger. That is basically a combustion chamber. And we are adding heat from outside. As a result, the heat is added outside. It's 2 to 3. This is the process 2 to 3. In the process 2 to 3, there is constant pressure heat addition. That at the point 3, it is a high pressure, high temperature gas. High pressure, high temperature gas again enters into the turbine, gets converted into the rotary motion, turbine rotates. As a result of turbine rotation, the compressor shaft also rotates, and as well as a power is being transmitted into the plant where the electricity is generated. Now, this gas which is coming out of the turbine is passed through the heat exchanger. It is somewhat hot gas, though the temperature has decreased, but still now it is a hot gas. This is cooled with the help of cooling water from the cooling tower. Cooling tower is a device which cools down the water coming into it. So that cold water from cooling tower comes into the heat exchanger and it makes a continuous circulation to cooling tower. Cooling tower details, you just now remember that it is the cooling tower which cools down the heat exchanger where the heat is rejected. But you need not know the details of the cooling tower. You will know it in 7th semester during your refrigeration air conditioning classes. There we will explain the details of the cooling tower. Here you just remember that heat exchanger is the heat exchanger where the heat is being rejected. The heat is being rejected by the cold water coming from the cooling tower. This is how the closed cycle works. This is how the open and closed cycle, both the cycles work together. Remember, in case of turbine, as there is movement of the shaft and the net work is transmitted outside, a part of the power goes in running into the compressor. So, the more efficient the compressor is, that means what is efficiency? The input power is more, input power is less, output is more. That means in case of compressor which is high efficiency compressor, that means less input power is required. So the load on the turbine power generated is less. So more power can be transmitted as W net. Try to understand what I am telling. The less power I give to compressor from the turbine is advantageous to me. I can transmit more power to the power plant. But if the compressor is inefficient, it is an energy guzzler, what happens? It takes more amount of work from the turbine. That means that is input is high, output is less. In that case, the efficiency of the compressor is less. And since the efficiency of the compressor is less, it works as an energy guzzler and takes a lot of power from the turbine output, which is used up in running the compressor alone, giving a less network to the power plant. This is a very important aspect of the engineering system. You remember, whenever you design an engineering system, your main intention is to produce maximum output and minimum input. That means less input means there should be less fuel used, there should be less rotation power required, And higher output means for what purpose it is used, the purpose is to be gained sufficiently. Say for compressor, the purpose is to compress the air. So it should compress the air sufficiently, taking less amount of power. That means if it compresses P2, P2 by P1 is very high, this ratio, compression ratio P2 by P1 is very high, and the power intake is very less, that means our intention is successful. That is the successful engineering. What is your performance? How your performance as an engineer is measured in an industry? As you go to an industry, it is seen what value addition you are doing to the system. What is value addition? Like you are put into an open cycle or closed cycle gas turbine plant, you will be told that you see how the compressor can work more efficiently. The compressor can be work more efficiently, including choosing different types of compressors. There are screw compressors, there are reciprocating compressors, there are centrifugal compressors. You have to compare the compressors. The reciprocating compressor is a very old-fashioned compressor. What happens in reciprocating compressor? It is a simple piston cylinder arrangement. What happens in that? The piston goes up, compresses the gas inside the piston cylinder arrangement. The friction horsepower loss is very high in reciprocating compressor. Frictional horsepower. In case of centrifugal compressor and screw compressor, the frictional horsepower loss is comparatively very less. So, as a first preference, you will omit out the reciprocating compressor. Automatically you come to centrifugal or screw compressor. Now you have to see the advantages of centrifugal and screw compressor. In centrifugal compressor, the vanes rotate and compression happens. In screw compressors, there are two screws. Screws, there are threads in the screws, and between the threads the gases enter and gets compressed. Now you have to see the advantages and disadvantages of both. Centrifugal compressor is easy to maintain because it can be maintained in the country India itself. A screw compressor is difficult to maintain because the screw threads are having particular pitch, particular diameter, particular distance, particular rotation. All these are very, very accurately designed, and generally Indian manufacturers don't do it properly. Generally, screws are imported from outside. So, screw importing from outside requires a minimum downtime. Engine remains shut down for a long time. Can you afford it? You have to see. Do you have a backup system for that? So I'm not talking about the subject. I am just giving you a gross idea as an engineer how your performance is measured. So those decisions are being taken by an engineer at the site depending on the prevailing conditions. And you will do the best thing for the site which produces the regular things in general. This is how we can maintain a total. Now, today we have talked about open type of gas turbine, closed type of gas turbine, and we have defined about how they work, the functioning of the compressor, the functioning of the different types of other equipments there. I think it is clear. In the next classes, we will try to clear the further things of advantages and disadvantages of gas turbine in general. Thank you for being with me.